Welcome. Now we are returning to our quest for simple, effective, efficient ways of finding derivatives. So we are going to look at operations on functions, and after addition and subtraction come multiplication and division. In this session, we will see how to differentiate products without actually multiplying things out. Derivatives do not distribute over multiplication. This is because difference quotients do not distribute over multiplication. The formal statement of the product rule is that the derivative of u times v is derivative of u times v plus u times derivative of v. Because addition and multiplication are commutative, we can write the terms in either order, we can write each factors in each term in different order. I will stick to this particular order for reasons that have nothing to do with this course, except that I always recommend people to write the terms in this order and explain the reason for that when we get to the quotient rule. So why is the product rule so much more complicated? Well, at least a little bit more complicated. We can explain this in several different ways. I prefer a simple geometric explanation. Geometrically, multiplication corresponds to area of rectangles. Area of a rectangle is length times width. So let's imagine a rectangle which is growing over time. X will be time, u is the width, and v is the length or the height in this picture. So we start with some rectangle at some position. A short moment later, the rectangle has grown wider and taller. And we want to look at the rate of this increase. So we want to know how much the area has increased first and then calculate the rate. To find the increase in area, I'm going to superimpose the new and old rectangles, the original position of the rectangle and the new dimensions of the rectangle. Position them so that one corner coincides. Then we have a border on top and side and a little corner up on the top side. We can divide this border into three segments. One on the top, one on the right, and one little corner piece. This is just like FOIL. So basically, if you think algebraically, the change in u times v is u plus delta u times v plus delta v minus the original value uv. You FOIL u plus delta u and v plus delta v. The first term in the product will be u times v. We subtract that off. What's left is the increase in the product, the change in the product. Now I need to find its rate, so I divide that by delta x. It's rather obvious as to what we want to do because we want to somehow get everything in terms of delta u over delta x and delta v over delta x. So when I divide by delta x, I can distribute the denominator. So divide each term by delta x. Since I can rearrange multiplication to some extent, I can first divide delta u by delta x, then multiply by delta v. The second term I can divide delta v by delta x, then multiply by u. What about the third term? I want to divide it by delta x. Should I put it under delta u or delta v? It turns out it doesn't matter, but I'm going to, for good measure, put it over both of them. But that's too much, so I need to multiply by another delta x to balance that. So delta u over delta x is essentially the derivative of u. Delta v over delta x is essentially the derivative of v. So the first term corresponds to the first term in the product rule. Second term corresponds to the second term in the product rule. What about the third term? What happens to that? Well, the first factor is du over dx approximately. Second is approximately dv over dx, but I still have this delta x. So when delta x is very small, this will be almost zero. Or more precisely, when I do limits, as delta x goes to zero, these two terms go to the two terms in the product rule. The last term goes to something times zero, and regular number times zero is zero. So that gives me the product rule. So to summarize, geometrically, when you add a border to a rectangle, it can be subdivided into three segments, one on top, one on side, one in the corner. The top is roughly the original width times the increase in height, which is rate of height times the time. The side is the original height times rate of the width times the change in time. And the corner piece will have area that's negligible compared to these two, and so we neglect it. So we get these two terms in the product rule. Next time we will see how to actually use the product rule.